ready to the countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Okay, we are live now. Bismillahirrahmanirrahim. Assalamualaikum. Good evening and hi to all teachers, parents and the wonderful students. So welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma, selamanya percuma. Okay, before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah. And for the non-Muslim, so please recite your prayers according to your religion. Okay, how's everyone doing today? My prayer is that everyone is in the best of health and ready to proceed with today's class. So let me introduce myself first. I am Madam Rosmaya as your moderator for today, and I'm a Form 6 Physics teacher at SMJKU Hua Kajang. So, and together with us is Teacher Ayu, okay, our host controller. Okay, she is a Form 6 teacher from SMK Sultan Sulaiman Terengganu. So our job is to make sure that today's session runs smoothly. And the most important person today is our presenter, Teacher Nun. Okay, she is from College Matrikulasi Negeri Sembilan. So let us give a warm welcome to our presenter. Okay, for the record, we are now live on Teacher Nun channel. So as a sign of support to Teacher Nun for the hard work in preparing today's lesson, so please subscribe her channel. And don't forget also to subscribe Teacher Ayu and my channel too. Okay, as usual, the lesson will last approximately 1 hour. The certificate link and the credit claim link will be given at the end of this session. So remember that you can only use Didik email and more email to claim the certificate. So for credit claim, you need to collect 1 letter and 5-digit codes, which will be announced separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. Okay, I would also like to remind students to use appropriate language and also use appropriate profile picture if you wish to post comments in the chat box. I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. So please give your full cooperation in making this class a lively one. So stay focused, and if you have any questions, so write on the chat box. And Teacher Nun will try to provide you with the answers. So before I give this session to Teacher Nun, okay, to continue with her presentation, I announce the first digit code for you all to claim credit. So the digit is number A11. Okay, I repeat, A11. So without further ado, please welcome Teacher Nun to start.
Okay. Hi everyone. Assalamualaikum warahmatullahi wabarakatuh. And good afternoon, good evening everyone. So I hope that everybody are ready for our class today. So my name is Madam Nun. Okay, you can call me Madam Nun. I am from College Matrikulasi Negeri Sembilan. Okay. So before we proceed to our class, I just want to introduce you. In our academy YouTuber, we prepare a lot of things for you, especially the free tuition class. Okay, and then I want to introduce you for the Form 6 and matriculation or PRAYU. We have physics teams. Okay, so our physics teams is led by Madam Rosmaya, and then teacher Su, teacher Habsahayu, myself, and also teacher Suhaya. We also have mathematic teams, okay, which is led by teacher Im, followed by teacher Zainaria and teacher Aileen, okay, for the mathematic tuition. And then for the biologist Prayu, we have Cikgu Faizah as the leader, okay, followed by Cikgu Fatihah, Cikgu Naini, and Cikgu Wawa. And then we also have chemistry, okay, chemistry team led by Miss Cikgu Shahnun. Okay. So now we will, with us also, we also have the perakaunan and economy for the Prayu, matrikulasi and STPM, led by Madam Fizi. Okay. So we have a lot of subject here actually. Okay, I will proceed to our discussion today, which is about the deformation of solid and heat conduction. Okay, I just want to welcome everyone. Suhaili, Alicia, Siti Aisyah, Kugan, okay, Fakrul Razi, Awais, okay, welcome. Are you ready to learn? All right. So for this first subtopic, actually this is topic 11, right? Deformation of solid. So before we go to the discussion, I hope that you have tried to answer the question that given to you. So before that, I just brief about the concept that related to the deformation of solid. Okay. If we have a rod, for example, referring to the figure, if we have a rod of initial length L naught and cross section area A, and external force exerted on the rod, so the rod will elongate with extension E or elongation E. So from this part, we will get the stress, okay, which is equal to force per unit cross section area A, and strain, which is equal to elongation over L naught. Okay, and then from the stress and strain, we have another very important terms for the deformation of solid, which is about the Young modulus, okay, equal to the stress over strain. Or if we substitute the equation of stress and strain, we get the equation for the Young modulus, which is equal to FL naught over AE. We will use a lot in our calculation, okay, today. And okay, we also have the graph. You also need to know about the graph of force against extension and also stress against strain. Okay, so referring to this graph, actually, what is deformation actually? So deformation is any physical change in shape or size of an object due to the external forces exerted on the object. So if you refer to the graph, there are two parts. The first part is the elastic deformation, which is occurs when the external force is applied to an object and it will change shape or size of the object, but it can regain its original shape after being distorted. But if the body does not regain its original shape or size after being deformed, it is called plastic deformation. So if you refer to the graph from point O to A and to B, it is elastic deformation, meaning that the object can regain its original shape after the deformation. But if the object cannot regain its original shape, so we call it plastic deformation. That's the important part. And another important part that relate to your final exam later on is what you will get from this graph. To graph actually force against extension and stress against strain. So for the force against extension, we refer to the area under the graph of graph force against extension. You will get the strain energy, which is equal to the area under the graph is represent the strain energy, which is equal to half Fe. F is the force, E is the extension or elongation. And for the graph of stress against strain, so you will get the strain energy per unit volume. Okay, strain energy per unit volume. So strain energy per unit volume given by equation of half times stress times strain. So that's the difference between the strain energy and strain energy per unit volume. So this is the equation that involved in the calculation for the final exam. Okay. So we go to the first question. I hope that you have tried. Okay. Hi Saranya. Okay, welcome to our class. Okay, first question. So those, if you have tried to answer this question, maybe you can write down the answer A, B, C, or D in the text box, and then we can discuss after that. Okay. So for question number 1, okay, a metal wire of length 75 centimeter and diameter 0.13 centimeter stretched by 0.035 centimeter when a load of 8 kilogram is hang on its end. What is the stress and strain in the wire? So there are two things that you need to calculate. You still remember the equation that I explained just now, right? But for the step, how you want to solve it, well, even it is the objective question, so my suggestion is you supposed to list the information given. But before that, because this is, I just want to remind you, when we talk about the wire, we consider the shape of the wire with the cross section of the wire is cross section area of the wire is pi r square. Okay. So referring to the information given, as usual, please change to the SI unit because we will standardize the unit that you use. So L 0.75 centimeter, R, okay, given the diameter, so actually hidden information is the radius, okay, of the wire. Okay, and then elongation 0.035 centimeter, so change to the meter unit. And then M is 8 kg. So we want to calculate the stress and strain. So of course, referring to the hidden information, what is the referring to the information? What is the hidden information? So you will get the hidden information, of course, the area of the wire. So you can calculate earlier the area. So next time you just need to you just can substitute in the equation. So you will you can reduce the mistake when you press your calculator later on. Okay, if you calculate the area, you will get the area is equal to 1.33 times 10 power negative 6 meters square. Okay, and then when you can use the equation for stress, first we need to calculate the stress. So stress is equal to F over A, and then because of the load is hang at the end of the wire, 8 kilogram. So actually the hidden information is the force is equal to mg. So you just need to replace in the equation, and then you substitute the value, and then you will get the answer. For the stress is 59 times 10 power of 6. So actually choices given to you, if you look at that, it is clear showing B. So actually because of the rest is different, right? Power of 5, power of negative 5. So the answer is B. But if you want to check, let's say if there are two answers, normally they will give you two answers for the first part. So if you want to check with the strain in the wire, so for the strain, we just use the equation elongation over L naught, and then we just substitute referring to the given information that you have write down, and then you will get the answer, which is 4.67 times 10 power negative 4. Do take note that strain, there is no unit because of it is ratio between the elongation and initial length. Okay, for the first question, this is on the application. You need to know what equation that you want to use, and the most important actually because of the equation is given to you. The equation given to you, so you just need to substitute correctly. To substitute correctly, very important for you to check all the information given is in the standard unit, in the SI unit. Okay, because so you can substitute any value, and the answers is also there. So please be careful. Okay, clear, right? So now we go to, yes, the answer is B. So question number 2. Okay. Cooper, actually even there are two calculation there. So the level is still C3. Just application of the equation. Okay, so you need to do the calculation faster. You have 3 minutes for each question. So question number 2. A copper wire is 4 meter long and 3 millimeter in diameter. So at the same time, okay, please list the information given with the SI unit. So as usual, hidden information 3 millimeter in diameter, meaning that the R, the radius of the wire is 1.5 times 10 power negative 3 because of millimeter. Okay, stretch 1.5 millimeter. So same lah, elongation 1.5 times 10 power negative 3. When the body is suspended from its end, determine the mass of the body. Okay, if the young modulus of the copper is 1.2 times 10 power of 11 Newton, okay, sorry, Newton per meter square. Okay, as in the list of information. So if you look at the list of information, I also write down the terms that you want to calculate. For example, the question want you to determine the mass of the body. So make sure that you put it a question mark there. So you remember that you need to calculate. You can focus on your calculation. You know you need to get the value for the mass. Okay. So to get the mass of the body, because of given the Young modulus, can you guess what equation that you want to use referring to the given information? So before that, because of R given to us, so we have the hidden information here, which is the cross section area of the copper wire. Okay, you can calculate earlier. And also to calculate the mass, where can you get the equation of mass? So which is from the F, where F is equal to mg. So you can use the Young modulus. Generally, the definition of Young modulus, stress over strain, and then the equation is F L naught over AE. Okay, and then our F just now is equal to mg. So when you substitute mg L naught AE, all the value, you will get the M. So can you guess what is the answer for the mass of the body in this case? Okay, anybody knows the answer A, B, C, or D? Or anybody have tried to answer this question? You can write down your answer in the chat box. Okay, you not try yet, but it is okay. It is a very good. You can listen carefully. Yeah. So if you calculate, you will get the answer, which is 32.4. Okay, congratulations, Kugan. Very good. Yes, Joy, the answer is C. Very good. Okay, so but take a look at the choices given. Make sure that you choose the correct answer. And sometimes they just change the unit, so you also need to be very careful. Okay, if you look at the answers, the choices given is quite nearer to each other, right? Okay, so very good, Kugan and Joy. So now we go to question number 3. So for question number 3, a steel wire of length L and diameter D experience strain of 7.2 times 10 power negative 4 when it is support certain load. If the wire is replaced with a second steel wire of the same length but the diameter is half D, the strain now will be, so you need to calculate the strain. Okay, so this set of question, it is it is related to two situation. Okay, two situation of the wire. So if you list the information, it's very important for you to use the subscript, as I always remind you, so that you can differentiate the first situation and the second situation. For example, first situation with the subscript 1, and the steel wire, the wire is same length for both situation, but the diameter is changed. Okay, and given the first strain, which is 7.5 times 10 power negative 4. So now we want to find the what is the strain where if the diameter is half. Okay, so in this case, this is my suggestion. If it is involved, it is a lot of question like this actually. So the hidden information is because of both situation, we use the same steel wire. So the Young modulus of the steel is equal. Remember, the Young modulus is depends on the types of material. Okay, and then cross section area, because of given the diameter, so we just replace R to the D over 2. So we get the equation for cross section area of the wire, which is equal to pi d square over 4. Either one, you also can use pi r, but pi r square. But in this case, because of the changes is in the diameter, so we refer to the equation of A. And then if you look at here, it is related to the Young modulus, so we just use the formula for the Young modulus. Okay, stress over strain, and then because of stress is equal to F over A. Why you need to change stress F over A? Because of in equation A, you can see the D. So we want to find the strain if the D change. We want to find the relationship between the strain and the diameter. Okay. Referring to the equation here, you will get that E is equal to F over AY, and strain is directly proportional or inversely proportional to the cross section area A, and because of A is directly proportional to the D, so strain also inversely proportional to the D square. From this relationship, Okay, you want to solve it. So meaning that the physics concept is here, and we can use the mathematical relationship when you want to find the strain when the diameter is half. So you use this relationship, which is strain 2 divided by strain 1 is equal to d1 square over d2 square. Because of it is inversely proportional just now, right? Just substitute the value. D2 is equal to half D. Okay, referring to the we have list here the information, and then if you calculate, you will get the strain when the diameter is half. It is equal to, what is the answer? Anybody want to try to answer? A, B, C, or D? It's look like simple calculation, but you still need to do that calculation. Actually, D1 is D. Okay, D1 is D. So here D1 supposed to D and D square, we can cancel both. So you can calculate a strain when the diameter is half. The answer will be equal to 2.88 times 10 power negative 3. Okay, so the choice is A. I hope that you get the answer. You can try. Make sure that you press your own calculator so that you can check either you press the correct value or you can get the correct answer. Okay, very good, Suhaili. You are right. The answer is A. Okay, congratulations. Now we go to the question number 4.
Okay,
Okay.
Teacher Non,
Yes, sir.
can
Yes.
can we announce the third digit code before you proceed with this question? Okay,
Okay.
so the third digit code, okay, for the credit claim is number 7. Okay, number 7. Okay,
Okay.
Teacher Non, you may continue.
Thank you, Madam Rosmaya. Okay, so please take note the credit, the code, so that you can claim later on. Okay, for question number 4, a stainless steel wire is pulled by a force of 80 Newton and it is extended as shown in the figure. So referring to this graph, find the strain energy stored in the stainless steel wire. Okay, so remember about the strain energy just now. There are two types of energy: strain energy and also strain energy per unit volume. So for the strain energy, you will get from the area under the graph of force against extension. So because of that, if you list the information given, F is equal to 80 Newton, elongation is 4, extension is 4.6. Okay, referring to the graph, times 10 power negative 3 for the millimeter. So U is represent the strain energy. You can use the strain energy. As I said, this represent the area under the graph. So when you do the calculation, you substitute the value, you will get directly the strain energy, which is equal to, if you calculate, what is the value for strain energy? You get the answer, which is 0.184 joule, right? So this is very direct question. So I hope that during the exam, for this type of question, make it faster. Do the calculation faster so you can save a lot of time. Okay? So, and then, yes, the answer is D, Alicia. Congratulations. Okay, very good. So now we go to the question number 5. For question number 5, uh, a, s- a stretched wire has strain energy per unit volume. Okay, strain energy per unit volume, which is equal to 4.5 times 10 power of 3 joule per meter cube. So what is the Young modulus of the wire if the extension per unit length of the wire is 2.15 times 10 power of negative 4? The hidden, it is there is a hidden information here. The first one is strain energy per unit volume. The value is 4.5 times 10 power of 3 joule per meter cube, and the extension per the unit length. So extension per unit length is represent the strain, right? Extension per unit length. So it is actually strain. Okay. So for strain, oh sorry, there is no unit here supposed to be. So please cancel the meter. There's no unit for strain, right? So 2.15 times 10 power negative 4 only. Okay, no unit for strain. And we want to calculate the Young modulus. Okay, so how you want to get the Young modulus? If you have the value for the strain energy per unit volume, we know that the Young modulus is equal to stress over strain, right? So how you want to relate the strain energy per unit volume with the Young modulus? So this is, you need to be creative with all the equation. Yeah? So for the Young modulus, meaning that we refer to the strain energy per unit volume first. The equation for the strain energy, because we know that the strain energy per unit volume, you get it from the graph of stress over strain. Okay, graph stress over strain. So it is area under the graph of stress over strain, which is equal to half stress times strain. And then we have strain here. Or if you want to relate with the Young modulus, what you're supposed to do, you find the relationship that can be related in this equation. So we know that, okay, Young modulus basically, this is the way how you want to identify what the question want. If you do not know the relationship, for example, given the strain energy per unit volume, but there is no Young modulus inside, so you can identify from other equation. Or you can see the definition of the Young modulus, for example, which is stress over strain. And if you refer to the given information and equation, we can change the stress, because of stress is not given to us in the question, right? Then you can replace the stress, which is equal to Young modulus times with strain inside the equation. Okay, you understand, right? From the definition of the Young modulus, which is stress over strain, rearrange the equation. Why you supposed to make the head of the equation stress? Because of, if you look at the information given, there is no stress in the value for the stress. So we can replace the stress inside the strain energy per unit volume. So when you replace the stress, then you can see there is a stress per unit volume and also the Young modulus in the equation. Okay, this is quite easy now, right? You just need to substitute the value for the strain energy per unit volume and the strain, which is 2.15 times 10 power negative 4. And don't forget the square here. And now you can calculate the Young modulus. So if you calculate Young modulus, what is the Young modulus? Which one is the best answer for the Young modulus? Anybody want to try? Or you have calculated earlier, just answer. No worries. Don't worry, yeah. Don't worry. Don't worry if you do the mistake. We always learn from our mistake, right? Okay, so anybody knows the answer or want to guess? A, B, C, not guessing. You need to press your own calculator and you're supposed to get your own answer. So what is the answer? If you calculate, you will get the Young modulus, which is equal to 1.95 times 10 power of 11 Newton per meter square, right? Everybody get this answer? Okay. I hope that you try. And of course, the answer is A. Okay. Quite easy, right? Actually, it is not. I cannot say this question is easy. If you look at the solution, quite easy. But you need to think how to relate the strain energy per unit volume with the Young modulus. Okay, let's say if you ask me, how, madam, we want to identify this type of relationship. So you need to try a lot. Of course, you need to do a lot of exercise. When you do a lot of exercise, you can see the equation that you use can relate with each other, and you know how to relate the equation with each other. So congratulations, Ang Chia Ying, you said A. Yes, the rest you're supposed to understand the step to solve the question. Okay. Now we go to the question number 6. For question number 6, two steel wire A and B have the same length, but the diameter of wire A is twice that of B. The wires are joined in series and hang vertically with a load at the lower end. So as shown in the figure, like in the diagram. So if the stress in the wire A is S, what is the stress in wire B? So this is same with the equation, the question number 4, if I'm not mistaken. There are given to you two situations, right? You need to identify what happened. Okay, if the A, for example, if the stress wire A, so what is the stress in the wire B? So when we list the information, because of both two steel wire, actually two steel wire giving you hidden information, which is the Young modulus for wire A is equal to Young modulus wire B. Because of both is a steel wire, the Young modulus is equal, even it's not mentioned in the question, not mentioned in the question. but you're supposed to understand. You're supposed to know the yang modulus is equal. The same thing. How you want to know, madam? You will ask me, right? So if you do a lot of exercise, you will see this trend. When given the same material, the yang modulus is depends on the types of material. Okay. So and then same length stated here. So you can write down LA is equal to LB, but the diameter of A is twice the diameter of B. So you write down the relationship, which is dA is equal to 2 dB. And then if the stress is given in stress for wire A is S, so what is the stress in the wire B? Okay, you can see clearly the relationship, right? We can use the stress equation, and you get the relationship between the stress and the, because of D is in equation of air cross section area, so you find the relationship between the stress and the area. Sorry. So A is equal to pi d square over 4. So stress is also inversely proportional to the d square. Okay, from this relationship, we use the mathematical relationship. We just substitute dA, which is equal to 2 dB. And then for the stress in the wire A, the diameter is dB, because so it is inversely proportional. So d square, you can cancel the dB. Sorry. You can cancel the dB square. You will get the dB, which is equal to how many S? Can you guess? So the answer is? Anybody knows? Yes, 4S. Okay? Is it clear, right? This is mathematics, simple mathematics. Okay, can we go to the next part? Or do we supposed to take a break for a while?
Okay. Yes, Madam Nun. We are already go live for 30 minutes. So I think we better take a rest now. Okay. Cikgu Ayu.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, welcome back, students. Before we continue before Madam Non continue with the discussion, so I think I better announce the 4-digit code for the credit claim. So the digit is number 3. I repeat, the digit is number 3. Okay, Madam Non, you may proceed with your discussion.
Okay, thank you, Madam Rosmaya. Sorry. Oh, Siti Nur Zulaika. Okay, congratulations. Yes, your answer is D is right. Okay, 4S. So please try yourself, right? Try yourself, yeah? So now we go to the second part of today's session, which is about the heat conduction. So the first part is the deformation of solid just now, and now the heat conduction. Excuse me. Okay. So for the heat conduction, okay, what have you learned in the heat conduction? So the first part is the rate of heat transfer, right? Which is the rate of heat transfer is equal to dq per dt. And the equation is negative k a dt per dx. Referring to this equation, there are a few important things, which is the first one is thermal conductivity, which is the ability of the material to transfer the heat. And the equation is, we just rearrange the equation of the rate of heat transfer. And then we have the A, of course, cross-section area, okay, of the conductor. And dt per dx, which is, we call it temperature gradient, okay, temperature gradient. So temperature gradient is the difference in temperature per unit length. So given by the equation of dt per dx. So for the change in temperature or the difference in temperature, please take note, The final temperature minus initial temperature, and dx is the length of the conductor. But in this case, you need to remember the heat transfer is only from the higher temperature to the lower temperature. Higher temperature to the lower temperature. In any cases, the heat cannot transfer from lower to higher. Supposed to be from higher temperature to the lower temperature. So final is lower temperature, initial is higher temperature. So we calculate the different in temperature, you will get the negative sign. But don't worry, because of, if you look at the equation for the rate of heat transfer, it is negative here. So actually, when you write down the equation, you're supposed to follow the negative sign. The negative sign will cancel with the temperature gradient. Because of temperature gradient is the decreasing of the temperature. Okay, so that's for the rate of heat transfer that you're supposed to understand with the equation. And then referring to the relationship of the temperature gradient, we have the graph you're supposed to study. You're supposed to know about the graph of temperature versus length. So we have few situations. For example, if the material is not insulated, so what happened to the graph of temperature versus length? So you will see the heat loss to the surrounding. Okay, there is a heat loss to the surrounding. So you will get the curve graph. And referring to this part, T1, if you want to understand the heat transfer just now from higher to lower temperature, so T1 is higher temperature compared to T2. Okay, and if you have a metal insulated material, so the graph for the temperature versus length is a straight line graph. Okay, and same thing at the T1 is higher temperature compared, it is depends on the direction of the heat transfer, so higher temperature to the lower temperature. And if you have combination of two material, for example, in series, for your level, for the matriculation level actually we just consider the two material in series, for we not consider the parallel situation because of different things. So for the series combination of two material, for example, material A and B and insulated, so the graph we will get the two different gradient of the graph. Okay, so in this case, same thing, we have T1, which is the higher temperature, and T2 lower temperature. We have another temperature that you need to consider, which is the junction temperature. Sometimes we call it junction temperature, sometimes we call it the temperature between the material A and material B. So in this case, if you look at the gradient of the graph, we can say that the thermal conductivity of material A is greater compared to the thermal conductivity of the material B, referring to the gradient of the graph here. So this is the relationship that you're supposed to know. And XA is referred to the length of the material A, and from this point to the end, this is the length of the material B. So this is overall that you're supposed to know under the heat conduction topic. Okay. Now we go to the question that relate, question number 7. So what is the amount of heat that will flow in an hour through an aluminium rod 6 centimeter in diameter and 1.7 meter long if one end of the rod is maintained at a temperature of 120 degrees Celsius and the other end is 30 degrees Celsius? Given the thermal conductivity of the aluminium is 240 watt per meter per degree Celsius. So take a look how you supposed to list the information so that you know you not miss any information in the question. Oh, before that, okay. Hi, Huzaifa. Okay, you are joining us. Very good. So you want to calculate the amount of heat. What is the amount of heat, right? So dq that you want to calculate, and then the information given 1 hour. So dt is represent 1 hour is equal to 3,600 second, and then the diameter you change to the SI unit. The length given is in the SI 1.7, and then the temperature, initial temperature, which is 120, and the second part, second end is 30 degrees Celsius. So K is given there. We want to calculate the dq. So now, referring to the information given, you can see that we can use, of course, we can use the rate of heat transfer, but we have the hidden information here. Our hidden information, because of given the diameter, you can calculate the area of the aluminium rod. Okay, pi d square over 4, so you will get 2.83 times 10 power negative 3, and then you can substitute in the equation one by one. Okay, for example, DT. If you list correctly the information given in the SI unit, so you supposed to get correct equation. This is very very important because of you miss one part of the units, you will get a different answers. This is the objective question types. So make sure that you substitute correctly with the correct SI unit, and then in this case, no worries with the negative sign as I explained just now, because of the temperature gradient is the decreasing of the temperature. So you also will get negative here, 30 minus 120 degree. So it will cancel with this part. Okay, very good, Kugan. Kugan said that the answer is C. The rest, how about others? Do you get the answer C? So if you do the calculation, yes, you get 129.45 kilojoule. So the answer is C. Congratulations, Kugan. Very good. It is look like very very simple solution, right? But if you miss one part of the item, either you calculate the wrong for A, or you change to the different or to the wrong SI unit, you will get the different answers. But luckily all the answers is there. Of course you will get the answer, but your answer is not correct. Please take note about that. Okay, now we go to the question number 8. Okay, what is the time taken in minute? Okay, time taken in minute. So I just directly put the DT because we want to find the time taken with the question marks. Okay, we know that we want to try to answer. Oh, Chia Yin also get the same answer. Very good, Chia Yin. You are right. That's easy just now for question number 7. Okay. Uh, and then 156 kilojoule of heat, meaning that it is DQ, flowing through the 4 meter square of a brick wall, 6 centimeter thickness. So please be careful. How you want to identify 4 is represent the cross section area. Take a look at the unit, right? So that because of this is meter square, so it is A, and the wall, the thickness of the wall is represent the length of the wall, 0.06 meter. This is quite hidden actually, quite you need to identify because of not mentioned. Given that the thermal conductivity of the brick is 0.2, so K is 0.2, and the temperature difference between the two surfaces of the wall is 10 degrees Celsius. They not give us the initial and final temperature, but they give directly the temperature, the difference in temperature. So take note. This is a very, 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 very important concept. When you list the information for the DT, well, even here it's stated that it is 10 degrees Celsius, but when you write down or when you want to substitute in the equation later on, you're supposed to put the negative sign. Why? Because of remember, it is only one concept for the heat transfer, heat conduction. The heat supposed to transfer from the higher temperature to the lower temperature. So when you calculate the temperature difference, you will get the negative value. Okay, so let's try. Yes, Madam Rosmanya, let's try. The rest, let's try to solve this question. So it is basically we refer to the rate of heat transfer equation, which is dq per dt equal to negative ka dt per dx, and substitute correctly the information given with the correct SI unit. For example, for the kilojoule, don't miss, kilo is 10 power of 3. And then we have changed the rest, 6 centimeter, it is equal to 0.06 meter. So make sure that you change to the SI unit, and the temperature difference is negative. Then the calculation. Actually, for the calculation, for the objective question, actually no problem if you put the negative positive, but when you do the calculation, I am worried. Luckily this is just a simple calculation. You will get the value, either negative positive, doesn't matter because you get the value. But if it is involved the negative sign too, it is involved the sum of the value. So very important for you to be very careful. Okay, so if you substitute, okay, Andrew Kugan, you said the answer is B. Is it correct for the time taken in minute? Take a look at the answer. If you calculate, because we have changed to the SI unit, you will get the DT is in second. But the question want you to calculate in minute, so you divide by 60. So you will get 19.5 minutes. So very good, Kugan and Andrew. Okay, be careful. Yes, Suhaili. congratulations, you have tried, but please be careful. Siti Aisyah also, please be careful with the answer. Read the question carefully. The time taken supposed to be in minute. So you're supposed to divide by 60 first, then you will get the answer. Here, the unit is not given here because of the question mentioned that you need to calculate in minute. That's why the answer is not mentioned the unit. So this type of question you need to be very 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 careful. Okay. All right. So good try, Suhaili and Siti Aisyah. Congrats, Kugan and Andrew. Okay, now we go to the question number 9. So for question number 9, okay, the answer is B. All right. For question number 9, it is okay. Don't worry, Suhaili and Siti Aisyah. Yeah? We always learn from our own mistake. So for this mistake, make sure that do remember not repeat the same mistake. Read the question carefully. Okay. All right. For question number 9, it is okay. Fakrul Razi. We learn, okay? We learn together. Okay. So 146 watt of heat flow between two ends of a perfectly insulated metal. So if perfectly insulated, meaning that no heat loss to the surrounding. It is a perfect flow of heat. Okay, in the material. So insulated metal bar of diameter 14 centimeter and length of 95 centimeter. So at the same time, please calculate the information that I list. Yeah, calculate the thermal conductivity. So I put K, which is with the question mark of the bar if the temperature difference between the two ends of the bar is 20 degrees Celsius. Temperature, okay, as usual, temperature different. Okay, temperature different is negative because of from higher to lower temperature. So the heat flow, 146 watt of heat flow between two ends of the perfectly insulated metal. Okay, so dq per dt is given by, actually given is dq, right? Okay, the area is 4 pi d square over 4. And then we use the rate of heat transfer. Okay, sorry. Maybe I missed the watt. Actually, watt per second, yeah, the rate. Oh, sorry, watt is the unit for power. So dq per dt, another unit instead of joule per second. It is watt. Okay, thank you so much. Actually, now, see, I am also sometimes too confused, right? Please remember, watt is also the unit for the rate of heat transfer. Okay, because of what is the unit for power? Power is energy, the rate of energy transfer, right? Or the rate of work done. It is a power, same unit, right? So instead of joule per second, it is the unit is also can be represented by watt. So don't confuse. Just now I actually confused. Oh, watt. I thought watt per second. So you too, make sure that please read the question carefully. All right, we use the rate of heat transfer, the rate of heat transfer equation. So we substitute the value and we have calculated earlier the area, cross-section area as it is a hidden information. So my suggestion, yeah, during the final exam, please calculate it outside from this equation. Okay? Because of you will reduce the mistake that you will done. Okay, you will do. So when we substitute the A and also the dt per dx, okay, because of x is 0.95 meter, you will get K, which is equal. Okay, very good, Google Sahili, you have answer. The answer is 450. You are right. Congratulations, marvelous, fantastic. You understand very well how to use the equation for the rate of heat transfer. Very good. Okay. So we go to next question. Okay, Alisha too. Congratulations. You are right. Meaning that I'm not worried at all. Okay, I know you understand about the watt unit, joule per second, all the important unit. Okay, Siti Zulaika, Pang, and you also get the same answer. Very good. Okay, now we go to the question number 10. For question number 10, okay, rod A of length 40 centimeter and rod B of length 60 centimeter are joined in series. The open end of A is maintained at 100 degrees Celsius, whereas the open end of B is maintained at the 50 degrees Celsius. Both rods have the same cross-section area. If the thermal conductivity of A is twice that of B, okay, find the temperature at the junction of this rod. Okay, this is very familiar question. Okay, very familiar. Normally will come out in the final exam. So I just list because it is a lot of information from this question. The length of rod A, B, the temperature at the end of both rod A and rod B, and the cross section because of it is same cross section area. So A is equal to AB, and then the thermal conductivity A is twice B, so Ka is equal to 2 kb. So this is very important concept. Yeah, please highlight it and what you want to calculate, which is the temperature at the junction. So we have a concept of because of at the end of conductor at the end of rod A and rod B, the temperature is maintained, meaning that the heat transfer is in a steady state. Okay, because of the temperature at both end is maintained. Okay, referring to the question. So the heat flow is in a steady state. So at the steady state, we have the concept of the rate of heat flow in the rod A is equal to the rate of heat flow of in the conductor B. Okay, and then we just substitute the equation. Now, can you see until question number 10, we still use the equation of the rate of heat transfer, which is very, very important. So the cupidity for the rod A, and another one things, because of this is two rod, many cases, it is a series combination of the rod. So the subscript is very, very, very important because of you supposed to substitute correctly. Doesn't matter it is a objective or structural question, please do the same thing. Okay, so that if you get if your answer initially not correct, you can recheck later on with your solution. Maybe you forget to put the sign or whatever. Okay, so in this case, because of negative, okay, first we can cancel the negative because of both in the steady state, referring to the equation, you can cancel the negative, and also the cross section area because of same, we can cancel. And you can substitute Ka, which is equal to Kb. So if you substitute this Ka, which is equal to 2 kb, so you can cancel the Kb. Am I right? You can cancel the Kb, and you can substitute the temperature at the end of A and at the end of B. So Tj is the junction temperature that we want to calculate. So when you substitute, okay, you will get the answer, which is, okay, Kugan, you said you get D. All right, very good. And then the rest, can you get the same answer as Kugan? Because of the answer is correct, Kugan. The answer is D. Very, very good. I know, I can see that you have prepared for the final exam. So this is actually the types of final exam question. You will feel it is very easy if you understand well how to use or to apply the concept and equation given. Okay, now we go to the question number 11. So for question number 11, uh, the graph shows the variation of temperature. Okay, this is the part of the graph, but please take note. Yeah, the graph shows the variation of temperature gradient. Temperature gradient with the distance versus length. Okay, or versus distance, for distance or length, the same thing. For two rod, which is R and S, which have the same diameter. So the rate of heat flow through this rod are the same. Okay, kalau if the rate of heat flow, meaning that it is in a steady state. So we want to find the ratio of the thermal conductivity of rod S to the rod R. Okay. So please refer to the given information. So from the question itself, you get that because of it's stated that they have the same diameter, so dr is equal to ds. Okay, so if the diameter for that rod is same, actually the hidden information is the cross section area of the rod, both rod is equal. So ar is equal to as. And then another hidden information, because of the the rate of heat flow is same, meaning that the cupidity for R is equal to the cupidity for S, and we want to calculate the thermal conductivity. If you just look at the question, it is not enough information, right, for us to do the calculation. All right, so how? Take a look at the graph. It is important if you have the graph, it is a lot of information from that graph. So what information that you can get from the graph? Okay, this graph is quite special because of even you're supposed to focus on the graph of temperature versus length, but this graph is temperature gradient versus length. But doesn't matter if you focus what you can get from that graph. For example, as I said, always I have remind you, for the information of the graph, you need to refer to the X and Y component. So for the Y component, for example, represent the temperature gradient, meaning that dt per dx, temperature gradient is dt per dx, right? Temperature gradient, different in temperature per unit length. So dt per dx for R, okay, if you look at the y-axis, it is represented by 10. So 10 degrees Celsius per centimeter. And for the wire S, it is equal to 5 degrees Celsius per centimeter. Okay, you get one first hidden information at the Y component. So how about X component? What you will get at the X component? Okay, be careful because of this is there is a hidden information here. You will see that the length for the wire R, rod R, is 15. So it is equal to 15 centimeter LR. How about LS? What is the length for rod S? If you look at here, if you're not careful, you will write down the length is 45 centimeter, right? But if you look at here, wire S is start because of it is connected in series. So wire S is start at 15 centimeter to 45, meaning that the hidden information for the length of wire S from the graph is 30 centimeter. So please be careful. Make sure that you carefully look at the graph and write down the information given. Okay, so because of that, referring to the concept here, which is the rate of heat flow is equal in rod R and S, meaning that it is at the steady state. So we just first step, make sure that you write down the equation first with the correct subscript, and then you substitute the value. Okay, when you substitute the value, we can cancel the A because of A is equal, diameter is equal, so A is equal. And then we want to find negative, of course, we can also cancel. So we want to find the ratio between the Ks over Kr. So rearrange the equation. And then you will get, this part is also you need to be very careful. You tertukar. If you change 5 over 10, you also can get the answer. But the answer is wrong. So please be careful. Ks over Kr is referred to dt per dx for R, which is dt per dxr is 10 divided by dt per dx for the rod S, which is 5. Then if you calculate, okay, you will get the answer is 2. Very tricky because of if you just want to congak-congak, for example, it can be 5 divided by 10, which is equal to 0.5. So you choose which one is the best answer. Yes, good, Suhaili. Very, very good. The answer is 2. So you're supposed to read the question carefully, okay? And the last question. I hope that it is a lot of trick. Yes, the question, you are right, Cikgu Faiza. It is a lot of tips and tricks in this question, yeah? So please take note. The answer is B. Now we go to the last question, which is question number 12. Okay. A composite road consists of rod M and N. Rod M of length 0.6 meter is maintained at 40 degrees Celsius at one end and 60 degrees Celsius at another end. Rod N of length 0.4 meter is joined in series with the hot end of M. It is a lot of terms, right? Okay. The other end of rod N is 80 degrees Celsius. Which of the following graph correctly shows the temperature against length for the rod? Okay, my tips. My tips. Okay, this type of question, it is a lot of information. So what you need to do? First, you read the question at the same time. Maybe you can maybe you can list the information given, or if it is quite technical, so you can sketch the diagram. Sometimes we sketch the diagram, it will show us clearly what is the question, what the question represent. Okay, sometimes we list the information, it is enough. But in this question, I'm sure, referring to this question, if you can sketch the situation between a rod M and N, you will understand more. Okay, for example, the first try, I just directly sketched the diagram. So it stated that rod M, length 0.6 meter, 40 degrees Celsius at one end, and the another end is 60. And then rod N, which is length 0.4 meter, joined in series with the hot end, meaning that end is connected at 60 degrees Celsius because of hot end. Okay, so you need to be careful to put where is the end supposed to be. and the other end of the rod end is 80 degrees Celsius. You see? So which of the following graph correctly shows the temperature against line? Okay, in this case, what is important actually? Remember, the heat transfer supposed to be from higher to lower temperature. It is a very important. Higher to lower temperature. If you look at the graph, if you look at the diagram, this is 40, this is 80, meaning that actually even the explanation is saying that M first and then connected to the N, but the higher temperature is at the end of the N material. Okay, because of that. And also, if you want to choose, let's say you not think anything, right? So you want to see, if you see all the choices given, it start with N, and then second rod is M. Because of that, you also can sketch like this. You can change because you understand that the heat supposed to flow from higher to lower temperature. So starting from 80 to finally 40 degrees Celsius. Okay, because of that, which one that you can kick out first? Uh, of course, C, right? Because of N, which is 0.4 meter, here is 0.6. So you can kick out the N first. And then which one that we not a good choice? Oh, wow, very good. All of you that start answering, the answer is A. Very good. So yes, the answer is A. So please take note, because of yang D, choice D, we also can you're supposed to ignore because of, you see, even the mention 0.6, the length, actually M is 0.6, but if you measure the length here, 0.6 minus 0.4, it is represent 0.2. So it is not correct, right? So the choice is only A or B. So congratulations. Wow, fantastic. Kugan, Andrew, Suhaili, Siti Aisyah, Alicia, congratulations. You have a correct answer. That's the answer. The answer is A. That's the way how we identify the answer, referring to the graph given, the choice given. Sometimes too, the choices given is also can help us to identify how to solve the question. You also can look at the choices given too before, if you want to understand what you're supposed to write down for the solution. Okay, so I think that's it for our discussion today. This is my last question for today. So thank you very much, everyone. So I hope that you can do your best, and maybe we will see another time for another chapter. So I give back to our fantastic moderator, Madam Rosmaya. Thank you very much.
Okay, so with God's grace, we have reached the end of today's session. Congratulations to those who are able to follow our session from the beginning till the end. So before we end our session for today, I will announce the last digit code, the fifth digit code for credit claim. So the digit is number 6. The digit is number 6. Okay, so all of you, please stop posting your comments for a while. And if you haven't clicked the subscribe button, so please do so. Make sure it turns to grey color, not the red color. Okay, and activate the icon bell so that you will not miss the next class session. Okay, then if you find that the lesson was beneficial, so click like and share to your friends on your social media. So spread and share the goodness. Okay, once completed, type done on the chat box before the certificate link is given as a token of thank you for your dedication in joining the free class, online class today. Okay, so link for the certificate and the link to claim credit are already given in the chat box. Okay, so please take note, the link will end half an hour after this live class. So make sure to use the EDD email or more email only to log in. So incorrect email used will not be entertained. So if you haven't got one, please apply. So the link to apply the EDD email is also given in the chat box. Okay, so if you wish to get more information on the online classes, so go to the www.academyyoutuber.com. And to those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all of the students for joining today. So remember that the more classes you join, the more credit you can claim. So feel free to share this free tuition class to your friends and teachers all over Malaysia. because this is the collective effort from all the teachers throughout Malaysia for all the students throughout the country. So thank you too for being a YouTuber Academy supporter too. So I think that's all for now. See you in another session. Ingat hashtag bermula percuma, selamanya percuma. Assalamualaikum. Stay safe till we meet again next week, same day, same time, on Sunday at 5 p.m. Okay, bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.